All right, Algebra 1. Welcome back, guys. We are in section 3 today, and we're working with still polynomials, but it's a little bit of a different format for this equation here. You're going to see in our title, we are still graphing, yes, but the format's changing, okay? And I want to let you know, in this given format here, this is not considered to be the standard format, all right? So the standard format, if we zoom in on this little paragraph here, this is the standard format that you're used to seeing, the ax squared, bx, and c. All right, and that you've actually already learned how to graph. You figured out how to get the axis of symmetry, the vertex, plug all that stuff in, and then you get your parabola shape. And in fact, if you have problems in this assignment where they give it to you in standard format, you don't have to change it, all right? I want to make sure that you understand you've already learned how to graph these, and you are not required to change it into that intercept format, which is what tonight's format is called, okay? So let's get back into just some of the basics about tonight, all right? This is the intercept format. A, P, and Q will all be actual values, actual numbers, okay? But the x's right here will just be variables. Those are just x. And of course, y is normally y. They're by itself isolated. Okay? So a little bit of info. All right, if you were given a quadratic function, but it's in the intercept format, you're going to notice all they put is a negative sign out front for this one, which would represent a, which would actually then be -1. Then you're going to be given this value of a 1 here and a -5 here. And what you are looking to do is solve those parentheses, all right? Because right here, what do we get from that? We get the x-intercepts, all right? If you solve the individual parentheses, x plus 1 equals 0, x is going to be a -1. And if you solve x minus 5 equals 0, then x is going to be a +5. Those values are the P and the Q values. Those are your x-intercepts. That is where the parabola crosses or touches the x-axis. Okay, and you're going to see me go through a few example problems doing that. Now, this negative sign out here, let's go back to that really quick. That's your A value. Your A value is a -1. If A is a negative, then that is going to make an upside down parabola, like that frown face, okay? If A, the value out in front, is a positive, then that is actually going to make a upward, open facing parabola, which is your smiley face, okay? All right, so let's take a look at a couple examples worked out here. So if you're given, again, intercept format, x-intercepts are P and Q. That is these values right here. And then when you're trying to find the axis of symmetry, which is this middle line, right, perfectly separating, cutting that parabola in half, you're going to figure out P and Q, add them together, and then divide by 2. That's going to give you the axis of symmetry, which is the x value. Then take that x value and plug it back in to the intercept format in those 2 spots where you see x, and then you're going to get your y value. And once you have that y value, that's going to be your vertex, which is going to be that point right there. Okay, it's either going to be the most minimum point or the most maximum point. And again, you'll see us do that. All right, this is saying if A is greater than 0, that means A is positive. Then you're going to have this positive smiley face shaped parabola. But if A is less than 0, in other words, think negative, then you would have a downward frown face style parabola. Okay, so let's take a look at one example problem, and then we'll do our own. So if this is what we're given in the intercept format, -2, then parentheses x minus 1, then x plus 3, step 1 is solve these parentheses right here, okay? So if you have x minus 1, then x equals 1. And if you have x plus 3, then x equals negative 3. Do the opposite. And that's what we're given right here as our p and q values. P and q, again, are the x-intercepts. So let's look at the graph down here. That's why you see these points, negative 3 and positive 1. That's right there. That's where the graph is crossing the x-axis. Now, if we go back and take a look at A, see how A is a negative value, negative 2? That is telling me that the graph will be a downward open, or that frown face shape parabola. So we now have the x-intercepts, and we know it's opening downward, the frown face. So now we have to do the axis of symmetry. We already have P and Q, so plug it into this equation here. P plus Q divided by 2. So 1 plus a negative 3 makes a negative 2, divided by a positive 2 makes a negative 1. So that's the x value of the vertex. That's how we get this negative 1 value right here. Okay, so take that negative 1. We're going to take that negative 1 and we're going to plug it in into both of those x values right there. That's what they did right down here. They substituted in negative 1 and they solved all of that and they got a positive 8. That's how we're getting this value here. Okay, negative 1 was the axis of symmetry, plugged in to get 8, put them together, that's your vertex. So if it's a downward open frown face shaped parabola, that is a maximum value that we just got there. Okay, so let's go ahead, try some of our own example problems here. All right, so let's do this first one. Okay, so for starters, we have a positive 3. So we know it's going to make an open upward smile face parabola. Now we have to solve these parentheses. That's going to be our P and Q value. All right, so let's go ahead and we're going to have x equals a positive 6 and a positive 4. All right, remember, we do that very quickly. X minus 6, the opposite is positive. X minus 4, the opposite is positive. So we know in our graph that we're going to have x-intercepts of positive 4 and positive 6. All right, so let's see if we can count that out here. Got to go a little bit further. So let's extend our graph. See if we can extend this out a little bit. Okay. So we're going to have positive 4, 1, 2, 3, 4, 5, 6. All right, so we're right there and right there. Then we need to get the axis of symmetry, which is P plus Q divided by 2. All right, so P plus Q divided by 2. And remember, that is right here, x value, axis of symmetry. Okay. That's going to be 10 over 2, which means that's going to be 5. Okay, so that is the x value for the axis of symmetry. And we're going to have to take this value and plug that into both of those x's right there. Okay. So let's go ahead and do that. We're going to have a 3 and then 5 minus 6. And then another one, 5 minus 4. So that's going to be a negative 1. That's a positive 1. And that's 3. All multiplied together. So a negative 1 times 3 makes a negative 3. So that means that our vertex is 5, negative 3. All right, so that was me plugging this x value in here and here. Then when we solve that, we got negative 1. When we solve that, we got positive 1. And then 3 times negative 1 times 1 gave us negative 3. So now we need to graph the vertex. So let's go ahead and go over 5, down 3, 1, 2, 3. And we are right there. And There is our nice hand-drawn parabola. Okay, so that's how you use the intercept format and graph it. All right, let's do another one. But this time we are given essentially a set of parentheses, and they're going to say squared. So that means same parentheses twice. So if you want it to be in the format that you just saw, we're going to put a -1, x plus 1, and another x plus 1. All right, that says do this twice. So that's why I wrote that twice right there. Okay, so it's a negative value. So it means we're going to have a downward open frown face parabola here. Notice they're the same, x plus 1 and another x plus 1. So that means that the only value coming out is x equals -1. That's my x-intercept. So simple enough. It's only crossing the x-axis one time where x is -1. So right there, that's where x is -1. Okay. Now, if we were to use the equation for the axis of symmetry, you're going to have a -1 plus a -1 over 2. So a -1 plus a -1 is a -2. Over 2 makes -1. Okay, so a -2 over +2. So this value right here is what we plug in for these x's. And you're going to see pretty quick, what does this all work out to be? Well, a -1 plus a 1 is 0. A -1 plus another 1 is 0. And a 0 times anything is still 0. So that means that when I take -1 and I plug it in for x and x, I get -1 plus 1 equals 0. So that's 0, and 0 times anything is still 0. So that means that my vertex is just -1 comma 0. Okay, well, if that's the case, then all I'm looking at is my value of a downward opening parabola right there. Okay, downward opening parabola with a vertex that is actually the same thing as its x-intercept. All right, so that's number 2. Let's do our last one here. Wanted to give you one that was back in standard format. Okay, so with standard format, you don't have to use the intercept method. All right, if you wanted to use the intercept method, you would have to factor the trinomial and then go through the steps that we just took, which is fine. You could do that. Or you could simply just simplify it and then graph it, keeping it as a trinomial, which I'm going to show you that method. All right, so what you want to see are 3 values right here that all share something. 2, 2, and 12 all share the number 2. So we're going to factor out a 2. All right, so factor that 2 out. Now you have a trinomial x squared minus x minus 6. Okay, and this is what you're really going to focus on. We're just going to be graphing that right there. Once you factored out the 2, it's going to create the same graph. It's just a little easier to get to that graph. Okay, so now let's review. What do we have to do to get the vertex? Okay, well, what do we have to do to get each of the x-intercepts? Well, to get the vertex, the equation for the trinomial, remember, is a -b over 2a. Well, it just so happens that b is already a negative, and when I put that negative with it, that's going to make b become a positive. And if b is 1, then we're looking at a +1 over 2 multiplied by a. Well, a is just a 1. So 2 times 1 is just going to give me a 2. So that value right there, the x is 1/2, that's the axis of symmetry. I take this value and plug it, actually we're plugging it in right here to this x and this x right here. Okay, so we're going to substitute that value in. 1/2 squared minus 1/2 minus 6. Okay, 1/2 squared. It's going to give us 1/4 minus 1/2 minus 6. None of these have common denominators. So now we have to get a common denominator. All right, let's go ahead and make that common denominator 4, which we can convert the other two, this guy right here, the 1/2 and the 6, to become a fraction with 4 in the denominator. All right, so what is this going to equal? 1/4 minus 2/4 minus, and let's see, that's going to be 24/4. So now all of these guys have the common denominator of 4. And we're going to go 1 minus 2 minus 24. It's actually a negative 25/4. So let's write that out. That equals a negative 25/4. Okay, so when we are putting this together as the vertex, I understand you're looking at two fractions and no one really likes fractions. You're just going to do your best estimating roughly on the graph where we are at. So I know we got a lot of work here. I'm probably going to have to erase a little bit. So hopefully if you need to, you can pause and you can keep your work in there. But I'm just going to clear out a little bit of space. So we can get the vertex written over here as a 1/2 comma negative 25/4. And there we go. And clear out a little bit of space right there. Okay, so that's going to cover us for the vertex. So let's go ahead and plot that. And so we're going to go 1/2, so barely to the right. And let's see, 25/4. All right, a little bigger than 6. So we're going to go to the right a little bit, 1/2. And we're going to go down, which I don't really have that kind of space. We're just going to go down and imagine that right here will cover us in terms of our negative 6¼ is what that works out to be. Okay, now let's go ahead and plug in 0. And what would that work out to be? Why do we plug in 0? We plug in 0 here and here for x so that we can get the y-intercept. The y-intercept is always the c value. So it turns out that my y-intercept is -6. And again, I know that I didn't really leave enough space here. But if we are saying that we went down for this value, just a little bit more than 6, then let's go ahead and go not quite as far down. And that's going to be our y-intercept value representing -6. And then perfect mirror image right there. We're going to have our mirror image parabola. Okay. So there we go. That is the third and final example problem there for section 3. Okay, guys. So remember, you got questions, write them down, bring them to class. I'll do more problems for you on the board. Make sure you feel confident and are working hard. Write down these notes and ask those questions. We'll see you guys in the next one.